don't know if you remember, but if you were told about what happens when you make a cup of tea at the top of a mountain versus our little friend down here. If this is at sea level, may as well make it look like it's at sea level. There we go. Your water boils at about 100 degrees C. If we climb all the way up this mountain, it could be boiling at, let's say, 90 degrees C. Essentially, there's less pressure up here, so down here at atmospheric, what is it, 14.5 psi or something like that, ish. Can't remember exactly. And the less the pressure is, the lower the temperature of boiling water. So this is exactly what happens with a peristaltic pump. So if you've got your ground and you've got a groundwater bore, and we've got the water about here, and we've got the peristaltic pump, which is a vacuum pump. So you've got the pump there, and you've got tubing going all the way down to here, and it's lifting this water. So, and for as deep as it goes, you're requiring more vacuum to pull this up. So if you get really low, so the theoretical maximum for this is, I think, 10.6 meters. And at this point, basically, you've got a full vacuum, you've got a pure vacuum in here. And what it's doing is it's boiling the water. So it's boiling it all off. So you never get a sample. And this is why using a peristaltic pump for sampling VOCs, volatile organic compounds, can be problematic, because you're boiling off those VOCs faster. So typically you want to avoid sampling any deeper than about 4.5 meters. And there will be some losses here. But perhaps you can quantify that, but also this is a very repeatable system. It's very easy to use. Because it's so easy to use, the chances of you acquiring a sample in a similar fashion are much higher than using other pumps, which means that you're able to compare your results much more easily. Now, if we do this with a bladder pump, like so, now we have a submersible pump here with our little controller, and that is essentially, you're compressing air down into here, and that air is squeezing the bladder inside and pushing the sample up. So this is ideal for VOCs because it's retaining everything, all those dissolved gases in the water. It's not boiling them off. The problem with this is that it's quite difficult to use. So you've got two sets of tubing in here, and you've got dials that you need to set correctly. And generally it's a lot more difficult to do this in a repeatable fashion than it is with a peristaltic pump. So yes, you get total VOC retention with this style, but because it's not as repeatable, your results may not be. So if we do this with a little target, here's our target. With the bladder pump, you may get us here, and then here, and then here, and then there, and so on and so forth. Whereas with your peristaltic pump, your grouping is going to be much tighter, and that's why you may actually choose to use this over the bladder pump, even for VOC sampling, because of that repeatability.